In this presentation, we have talked about line integral. Any integral to be evaluated along a curve is called a line integral. On many occasions, we have seen integrals like integral c pi dr, integral v dot dr, integral v cross dr. Here c represents the contour. Here pi equal to pi of x, y, z is a scalar point function, represents a scalar field. V equal to v of x, y, z is a vector point function, represents a vector field. See the contour along which the integration is carried out. Now we can see the contour, say this is the contour C. A is a starting point, B is a final point. Consider this origin or the position vector, then this dr. dr is equal to I into dx plus j into dy plus k into dz. This is the contour. The contour along which the integration is carried out. Now come to our first integral, integral pi dr. This is integral pi dr, integral pi dr is equal to I into pi of x, y, z into dx plus j into pi of x, y, z into dy plus k into pi of x, y, z into dz. Say, consider this is equation number 1. Now see here, dr is equal to I into dx plus j into dy plus k into dz. Pi is a scalar function. Pi is a function of x, y, z. So integral of pi dr equal to I into integral pi of x, y, z dx plus j into pi of x, y, z dy plus k into pi of x, y, z dx. If you want to make the integral with respect to x, we should know the dependence of y and z on x. Then only we can evaluate this integral. Here we should know the dependence of x and z on y. To evaluate this integral, we should know the dependence of x and y on z. Now come to the second case, integral v dot dr. Integral v dot dr equal to, see, v value is known to you, it is a vector point I into vx plus j into vy plus k into vz. So that this is I dot I1 integral vx of x, y, z into dx plus vy of x, y, z into dy plus vz of x, y, z into dz. Yeah, we have to put contour. Here also we have to put contour C. Now v dot r, this is I into vx plus j into vy plus k into vz. dr equal to I into dx plus j into dy plus k into dz. So that vx of x, y, z into dx, already we have given v equal to v of x, y, z is a vector point function, represents a vector field. So Vy is also the function of xyz. Vz is also the function of xyz. This is the value of V dot r. Then V cross r we should know. V cross dr. For that we should take the determinant V cross dr equal to I j k Vx Vy Vz dx dy dz. This is I into Vy dz minus Vz dy minus j into Vx dz minus Vz dx plus k into Vx dy minus Vy dx. Then this is equal to I into Vy dz minus Vz dy plus j into Vz dx minus Vx dz plus k into Vx dy minus Vy dx. Now I have to substitute this here. V cross dr, which is equal to integral I into integral Vy of xy z into dy, not dy, dz. dz minus Vz of xy z into dy. Plus j into integral Vz dx minus, see, here also we have to put Vz of xy z into dx minus Vx of xy z into dz plus k into integral of Vx of xy z dy minus Vy of xy z into dx. Here C contour C. These are all unit vectors. This is the value of V cross R. Put this is V dot dr. This is equation 2. V cross dr. This is equation 3. From the equations 1, 2 and 3, one thing we should know. I, j and k are constant unit vectors. From equations 1, 2 and 3, we may say I, j and k are constant unit vectors and are independent of dr. So that their direction and magnitude are not changed, so that they are present outside the integral. They are constants, only due to that reason they are present outside the integral. To understand more about this, consider the first equation. If you put pi equal to 1, say this also, see in equation 1, if you put pi equal to 1, see pi dr equal to I into pi of x y z dx plus j into pi x y z dy plus k into pi x y z dz. This is the value of pi dr. These are all, see, if we put pi equal to 1, then contour pi dr, contour integral of pi dr, which is equal to integral dr. This describes the motion of the particle from the point A to B on the curve. If pi equal to 1, we may get integral pi dr equal to integral of dr. Integral dr with a c contour, that is equal to motion of a particle from the point A to point B on the curve C. This represents motion of the particle from the point A to B on the curve C. In this way, we should understand the term line integral.